So my name is Zach Smith, as I introduced in the beginning of today. I'll be presenting about the improvements that have been made to the FFlex and Mesher in V9R3. We really think that the FFlex and the inclusion of nonlinear flexible bodies is a real strength for RecurDyn, and it's been a constant source of focus for Function Bay to make improvements, and V9R3 is no exception to that. There have been quite a few changes and improvements to the FFlex and Mesher. Just a brief overview of kind of in a list form of what we're going to be going over. The improvements that have been made. So for the FFlex, there have been 10 new functions, 15 upgraded functions, and then there have been various bug fixes and changed functions as well. And for the Mesher, there's 6 new functions, 6 upgraded functions, and various bug fixes and changed functions as well. So we'll be going into some of them brief overview, and some of them will break out into RecurDyn and actually take a look at how it works and get a little bit of a feel for what these changes actually look like. All right, so starting with the preprocessor, there have been enhancements to make, especially when you're looking at large files with a large number of elements, and they include these flexible bodies. There have been some significant improvements to how fast those files will open and close. They won't take as long to boot up every time that you open up those files. And it's also faster to switch from the FFlex body edit mode to the assembly edit mode. And this is really noticeable when it's a significantly large file, when you have a lot of elements and a complex RecurDyn model. And so just as a rough estimate, it's about 1.5 to 2 times faster there. And then kind of a similar expectation with the post-processing. Some of those post-processing features can take a little bit to run when you're including a lot of elements, large flexible bodies, complex models, and so there have been improvements to make that run faster, specifically the animation result file size reduction, RFA files. There's a new feature there that you can optionally make those files smaller. We'll talk about that a little bit more later. And also, when you're importing and playing an animation, that can run much faster in V9R3 compared to V9R2. And along those same lines, the export of the RMD file of the FFlex model, that can happen about 2.5 times faster in V9R3 compared to V9R2. Now there are quite a few new features that have been added to the FFlex, and this first one here is deleting the unused materials and properties. You may be familiar with the delete unused markers, which is the top one there. That's an old feature that I use quite a bit. When you've been making a lot of edits to your model, you're deleting bodies, including new bodies, deleting joints, including new things. A lot of times you end up with just a lot of unused markers, and so that's a quick feature to just delete all those unused markers. And it's a similar feature with these delete the unused materials and properties. If you had been adding quite a few new materials, new properties, as you've been making edits to your model, you can come up with quite a list. And so that's a quick feature that you can just click that once and it deletes anything that's not being used currently. That's a way of simplifying your model visually to make it easier to understand as you're going through your model. And this next option here is this line option for add remove continuous. So the add remove continuous is the old feature here that you can, I guess the old way that it would work is that you'd click on something that's more similar to this patch definition, and you click on something and it adds all the nodes within a certain tolerance. And something that's specifically new is this new line feature that will add nodes in a line if you're defining a node set. And that feature, having the option to select either patch or line when you're doing this add remove continuous, is actually in a few functions. The node set, I know it's in the beam elements, so that is something that will be included in a few different features.
So just a comment about the mute. So a quick comment about the RMD file. I'm not sure how many people have worked with it, but the RMD file is actually an ASCII file that is always exported every time you do a solve. So this 2.5 times speed up means that there'll be less of a lag between when you kick off a simulation and when you see the solver actually running. The other thing is that you can just also manually export the RMD file. And since it's an ASCII file, if you are wondering about differences between like two different models, by exporting the RMD file from each of the models, then you can use whatever tools at your disposal to do a comparison of these two ASCII files. Or the other thing you could do is maybe go to a certain section of the file and then do some kind of comparisons on that from one model and the next. But anyway, that if you ever want to have access to an ASCII representation of the model, that's what the RMD file is available for.
Thank you. I've actually been doing quite a bit of that lately, comparing the RMD files. There's a useful feature that's built into the Notepad++, that you can just easily compare those RMD files against one another to see if there's any difference between the models. So I'll briefly go into RecurDyn just to demonstrate that that one feature. So this is something that we're going to be looking at tomorrow. I may make some adjustments to this mesh before we actually use it tomorrow. So I'm not completely satisfied with these corners, but for demonstration purposes, it should probably be fine. But if I was actually trying to get useful information, maybe I'd want to make some adjustments to the mesh. But I'll go ahead and quickly demonstrate the node set. And so if you click on one of the options of the set is to make a node set. And there's these new features to select between patch and line. And so I'm going to go ahead and select the line there. I'll leave everything else the same. Go ahead and click on the add remove continuous. And so if you zoom in on that a little bit, it'll actually select two nodes as you're trying to select something. So if you're just scrolling over your elements, it'll select two nodes at a time. And so if you click on one of those nodes, it will create a line and add all of the nodes that are in that line. So add in one direction, it goes in each of those directions. So it's a quick way to add all the nodes that are in a line there. So just finish operation, and then you have your node set there. Oops. All right, and as they're adding more and more features to the mesher, it can get a little bit cluttered. So they've made some simplifications and reordered things a little bit to make things easier to look at and include it in a more intuitive way. And so the order of the icons has been changed to fit the normal work order. So in V9R2, it was a little bit of a random inclusion of these icons, and in V9R3, the way that you'd want to look at this is from left to right, and typically that follows the order of what you do when you're going through a mesh. You first refine the geometry. The assist is included if you have things like joints or contact in your on your body that you're trying to preserve as you're going through your mesh. You'll use this assist function. Imprint points and lines and patch sets. We'll talk about that a little bit later. And then you'll go through your mesh process, go through some processes of actually refining your mesh, and then you can check what your mesh looks like, do things like merge multiple flex bodies. So typical process is now left to right rather than looking for the icons individually. All right, so the local remesh was something that has been included in previous versions, but it's been improved for V9R3. So in previous versions, you'd have to define each of these surfaces individually, and you'd have a list here of individual surfaces. And now for this local remesh, you can select multiple surfaces at the same time, add them all at the same time, use the same properties for max element size and min element size for all of them, and then it adds them all into a single line there that's easy to work with. And similarly, when you're adding these surfaces, it's very useful to use the add remove continuous option that you can add multiple surfaces at the same time. And I will go ahead and show how that works as well. I'm going to show the basic process kind of from the beginning, so you get an intuitive feel for how this works and how some of these new features play a role. So this is a simple model that we use sometimes, that it's good as a basic model that just to show off some features that doesn't take any time at all to run. So this is a basic Geneva wheel here, and some of the important features of this that we're going to be trying to preserve here is the contact between this pin and the wheel here. And we're also trying to preserve this joint here. There's a revolute joint and a spring, which is, I believe, just a damper at the moment. There's no spring force, it's just a damper. And so we want to go ahead and include all of those. We want to preserve the contact, preserve the joint, preserve the spring damper there, and mesh it. And so we're going to be doing something that, we're going to be doing something that was included in previous version, which is this G Manager. And so I'll click the G Manager. And the G Manager is a way to mesh things, and the G Manager is the easiest way to preserve all those things like contact and joints so that you don't have to redefine everything manually. And so I'll click the G manager there, select this body. This is the one I want to mesh, and I want to convert that body to a full flex. I'm going to go ahead and mesh it myself, and this is saying that I want to preserve all these things that are in the model. I want to preserve any forces, contacts, joints, any of those things that are in the model. I want to preserve that, and I'll go ahead and click execute here.
Question. It
Yes.
said to present Geo Contacts. What if I have any other contacts in the model, for example, solid contacts? Will it also be preserved or not?
Right. You do need to use Geo Contacts for the full flex.
Okay.
The Geo Contacts are the only ones that actually work with the full flex.
Okay. All right. Thank you.
Okay. And all right. So there are all these options here that are still there, but really we're focused on this mesher, and this is where things have been reordered. And so we're following a left to right process here using the Geo Refine. And so this is where you can do things like remove some edges. You can remove small features from this part that you're trying to mesh. And so you can see in this part that these holes are something that we'd want to remove. Otherwise, we'd need to include very small elements around there to refine in that region. And so I'm going to go ahead and check this refine small features. I'll select one of these holes. Go ahead and click finish. And so when I press the select button and select that hole, it actually takes a measurement of what the size of that hole is. And it doesn't automatically update this field in case that measurement isn't something that you want to keep. All you're doing here is taking a measurement. And so if that is something that you've decided you want to remove, you go ahead and just copy and paste into that remove small feature option. And so I can go ahead and click preview, and when I click preview, those holes have been removed from the part. And so that is all that I wanted to do in that GeoRefine option. I'll leave that as is. I'll click this assist modeling, again working from left to right as a standard process. And this is where, because I'm using this G manager, it's trying to preserve the joint, preserve the spring damper, and preserve the contact. And so this is where you see how it's trying to preserve that. And so it's trying to preserve this revolute joint, and if you click on it, you'll see the surfaces that it's going to pull from to make a force distributed rigid element. And so it's going to take elements from all of these surfaces and connect it to a single point to make this revolute joint. Now, it didn't quite do what I wanted it to do. I would rather it take just from this inside surface rather than the entire body here. So I'm going to make an edit here. And rather than use that surface, I'm going to select just that inner surface. And so it did the same thing with this rotational spring, that spring damper. So I'm going to go ahead and select again, select that. And for the contact, it's in order to preserve the contact, it needs to make a patch set. And that's one of the things that you can do manually. It needs to make a patch set on where the contact's going to be. And so you can see where the contact was already defined with all of these regions where that pin can come in contact. And I'm going to go ahead and leave that as is. And this is something we'll do in the next example, but we won't worry about this imprint function yet. And now we're going to go ahead and go into the auto mesh here. And we're not too worried about getting something that's a great mesh. We'll get something that's decent, but we're just showing off the features here. So I'm just going to go ahead and select 4 and 1. Gradation factor and chordal error ratio are things that were included in either V9R1, I think V9R1, and there are ways of defining how accurately you want to represent circular features in your part, and also how much you want there to be a gradation between small elements to large elements in your part, but we won't worry about that for now. We will focus. All right, so that meshed it, but actually the visualization there is a little bit hard to see. And so I'm going to go ahead and go into the display here. And the display is a little bit easier to use now. You can easily play around with these parts to turn them off and turn them on. So this is just, all we're looking at now is the patch set where the contact's going to occur. And so I can turn off the patch set, turn on the elements again. And really what's making that hard to see is the mesh line color is close to the element color. And I mean, it's not too important what that actually is, but so you can see what the mesh actually looks like there. So we'll go ahead and close that. And now I'm not satisfied with that, so I'm going to use that local remesh feature. And so that's this option right here. Again, kind of working left to right on the mesher section there. And so I'm going to go ahead and use this add remove continuous and add. And now there's all of these different surfaces here, but if I click on one, it'll actually add everything that's within a certain tolerance, and that's kind of what I'm looking for the moment. If you click on something else, it will take away what you've already done, so you hold down Control, and there you go. And we'll just, we don't need to get everything. We'll just leave it at those 3 so that you can see how the local remesh compares. Go ahead and click Finish. And maybe I want something significantly smaller for the local remesh. So I'll say the max element size is 1, the min element size is 0.5, and it applies that to all of those surfaces that I selected there without having to select those individually. I go ahead and click mesh there, and you can see how the mesh was refined in those regions specifically, based upon that local remesh. Okay, so that's what I wanted to show for this example.
Zach, one
Yes.
question. When you preserved the revolution joint, does it mean that RecurDyn has automatically created the FDR element?
Yes, so
because it is hard to see because of the screen color. And yes, okay,
right.
I see it.
So if you zoom in there,
yeah.
That's where that FDR element was created. And yes, so that's automatically preserved, but I did have to go into that assist modeling to select which surface that takes it from. So when I select
how
that,
can you be how to ensure that the center of this revolution was properly selected as a center of this geometrical opening? Did you have to select the master node or slave nodes or something like that?
The master node is automatically created at the point where the revolute joint was originally defined in the model.
Okay, all right.
So you don't have to manually go define where that happens. You already did that when you created the joint.
Okay, got it. Thank you.
Yep. All right, so just a small update to the manual mesh here. So if you have a 2D mesh, you can change that into a 3D mesh using this the manual mesh feature. So the manual mesh was included in previous versions. There are just a few new features that you can use now. And so it now supports curve, surface, edge, face, line set, or patch set that you can extrude from. And also, there's these two new options here that you can include a scale or a twist when you're doing a manual mesh. So this one, that's just a 2D box there, a square. If you include a scale that's less than 1, then as you're extruding it, it gets smaller. And if you include a scale that's greater than 1 and extrude it, then as it goes up, it gets bigger. And then there's also, you can include a twist. And here we have a kind of a gear example where including a positive twist angle. As you extrude it, it'll twist the mesh in one direction. And if you include a negative twist angle, it'll twist the mesh in the opposite direction. So just a couple new features to make the manual meshes a little bit easier to use and a little bit more useful. There's still a fairly limited number of cases in which you'd want to use a manual mesh, but it's starting to get a bit more useful. Now going into this imprint line and offset edge imprint. So when you have multiple bodies, this is especially useful when you're using the multi-mesh, which we'll talk about on the next slide. But when you have multiple bodies, there's oftentimes features from one piece of the geometry that you want to include on the second piece of geometry, so that that is specifically included on your mesh. So there's a certain line where you want elements or that you want your nodes to line up with, or there's a certain patch set where you want that patch set to line up with a second piece of geometry. And to really demonstrate this, we'll actually go into an example so that you can see how that works a little bit. But it's very useful for lining up two pieces of geometry and having a little bit more control over how this mesh is going to happen when you're just using this auto mesh. And so kind of similar with the offset edge imprint, we've had this ability to imprint these lines, imprint these edges, but now you can not only have the original edge, but you can also offset that and use that as an imprint as well. And so in V9R2, I guess to back up a little bit, so oftentimes when you import geometry from CAD, the way that it's imported actually contains multiple solid bodies in what's considered one body in RecurDyn. And so when you're meshing these bodies in V9R2, the only way that you could really deal with that is by using a unite feature in RecurDyn. And now you have this option to do a multi-mesh. So when you mesh one body, it doesn't get rid of the other bodies that are in your part. And this is another example where it'll be a little bit easier to see when we actually go into the example. All right, so here I have a fairly simple geometry here. So it only has one body, and it's labeled crank here. But when I go into the body edit mode, it's actually composed of what's labeled as a crankshaft and a flywheel. And so there's multiple bodies that are contained in this one body here. And actually that is what we're going to do right now. So one of the things that you want to do is include this this imprint here, and so these two bodies intersect. So I'm going to use this imprint intersection imprint, and I'll go ahead and select the flywheel here and the crankshaft second, and so that's really all I needed to do in that part. And I think, oh, it said it was performed successfully. Okay. And so that's just a way of defining how those parts interact. And so when I go ahead and exit here, and so now I'm going to mesh these bodies. And so previously in RecurDyn V9R2, if you meshed one of these bodies, I guess the second body would disappear, and you'd be left with one meshed body. But now I'll go ahead and mesh this, and I'm just going to use 5 and 5. I'm going to change that to solid 8 element, and we'll go ahead and mesh it like that. It's taking a little bit longer than expected. Okay, so that body was meshed successfully, and so now what I'm interested in doing here is actually defining where these two bodies are going to be joined together. And so in this case, these bodies are going to act, maybe they're press fit in some way so that they act as one body, but we're actually going to make this made out of two different materials. And so this one body's meshed, this one other body is not meshed yet, but we're going to mesh this and then merge it together so that it acts as one body. And so I'm going to go to the display here, and I'm actually going to oh, what am I looking for? Oh, here we go, show geometry. So I click the show geometry there so that we're only looking at this body, and we're going to go back to where those two bodies intersected there, and I'm going to create a patch set in that region. And actually I need to do the add remove continuous. Hold down Control, select multiple, finish operation. So now a patch set was created in that region. Did I exit? I exited. All right, I made an error there. Oh, there we go. Geometry. And so I'm going to go ahead and go back into the display and turn on show my geometry again. And this is where I'm going to use this imprint patch set. And so here I'm selecting a patch set to imprint onto this this new geometry, the flywheel. And the patch set that I defined previously is already there. I'm going to go ahead and select that one, select OK. I think I accidentally exited and went back in, and it created a problem. But I'll go ahead and show the process there of what that would look like. So I included an error there. And so to go through the process, I'd go ahead and click Mesh again, select 5.5, and I can change the material property here to something else if I want to. And so P-solid, or I can include a new one if I'd like to, but I'll go ahead and click that as it is. And here is where I just click Mesh, and had I not done what I had done previously and exited out, the patch set would actually line up with the other geometry, and based upon that imprint patch set, the nodes would actually perfectly line up with each of these geometry, with both the geometries. And at this point, I can select the flex merge and select the two bodies. And so the two bodies are automatically included here. The topology 1 is the crankshaft there. Topology 2 is the flywheel, and you can have a distance tolerance there. And that's how you'd go ahead and merge it together. I included an error with the imprint patch set, but that's the process that you'd go through to do that. And now these two bodies would be merged together.
So basically, as a result of this, so basically the patch or the nodes in the patch set of the wheel, like on the inside of that opening, they match the corresponding nodes on the neck of that shaft, right?
Right. And so then once you merge them together, it treats those nodes that previously lined up perfectly because of the imprint patch set now that they line up perfectly, they can be treated as a single
One.
node that's shared between them.
Okay, all right.
And you can have different different material properties for each of those bodies, and yeah, you can make some easy adjustments to things like material properties between the two. But all right, so looking at the cross-section display of beam elements. So when you include beam elements in your model, you have this option to actually show what the beam cross-section looks like. And so there have previously been all of these options to include beam elements of different cross-sections, but you could previously only show the circular cross-section. And so this is just a visual feature. The physics was included previously, but now we can have the option of including visually what these different beam elements would look like for I-beams, for different square cross-sections. Different cross-sections are now included there. And so that's just a checkbox that you click to show the beam cross-section.
Hi, Zach.
Yes.
Can you tell me what those stress recovery points are?
The
Stress recovery points on the left side, like a table.
stress recovery points.
Yeah. There is like a 5x3 table. Yeah.
I am actually not familiar off the top of my head with what those are. Brant, are you familiar?
Yeah, so you can name the points, point locations where it's going to actually calculate the stress, in that beam element. So it's in the local YZ coordinate system.
Okay.
Okay. So those numbers will change based on the beam cross-section radius?
Yeah. Yeah, I mean, they do tend to update according to the size of the cross-section.
Mm-hmm.
I do, yeah, I'm pretty sure that you have to manually input all those numbers though, correct?
I thought the starting values were put in there.
If you import it, at least if you imported the mesh from somewhere else, then those values are already.
Those values are defaulted to 0 if I try to import the mesh from some other software.
Oh, really? Okay. Usually I've seen it already predefined. I guess we can. I can take a look at your mesh, Samuel, if you want to send it to me.
Sure.
Or something. Yeah.
Okay. Yeah, that's something certainly I'd need to look into the documentation a little bit for, but we can look at that later. So yeah, the new feature here is just a simple visual visual feedback.
Zach, a very quick question about the previous slide that you were showing how to mesh those elements. When I'm still talking about this flywheel and the shaft. When you mesh the wheel, and in order to make sure that these meshes are kind of would merge successfully, do you need to select the same type of mesh for the wheel as you have meshed the crankshaft width and the size of the mesh element? Does it matter, or RecurDyn will do everything by itself?
I know that they do not have to perfectly align, but I think that if I'm remembering this correct.
Yeah, for the crankshaft, you selected the tetrahedral 4. Do you have to have tetrahedral to select tetrahedral 4 for the wheel, and also size of the? Do you need to match the size of the elements, or it would be not necessary in this case?
So some of that will be done automatically. I know that I've had meshes that did not perfectly align, and RecurDyn will go ahead and make some adjustments so that at that one point where you've defined that patch set, at that one point it will be the same size, but then it can there can be some gradation from that point. I don't know to what extent that might cause a problem if they're vastly different. You may run into some problems if there's large differences in between them. But
all right, thank you.
Some of that can be done automatically.
I see. Good. Thank you.
All right, so the orientation reference marker for displacement contours. So I guess kind of by default, you're looking at more of a global reference frame for X, Y, and Z, but you can select a marker that's in your model as a reference marker, so that when you're looking at the contour information, it'll look at something in a more local reference frame for X, Y, and Z. So if you want to reference a specific direction for your results and look at the contour in that direction, you can now do that by including this reference marker. There are two new shell material properties that are included in V9R3. There's one called orthotropic 2D, which corresponds to the Nastrans Mat 8, and also anisotropic 2D, which corresponds to Nastrans Mat 2. And so that gives a little bit slightly different features that you can work on that have been requested by some people. There's also this beam stress strain recovery for RFlex. So in V9R2, there's just this displacement contour, and V9R3 you can recover the strain and stress. The RecurDyn temperature load file. So this is something that would be performed in external structure analysis software, and from that structure analysis software, you'd come up with this RTL file, and this RTL file it's this RecurDyn temperature load file, which is a CSV file format that you can now import into RecurDyn to use for in your simulation. So this is something that's exported from another software and then imported into RecurDyn.
Mm-hmm. In what format? Like, for example, if thermal analysis were done, let's say in ANSYS, what format should the output file be created in? So that because definitely ANSYS probably doesn't have this RTL option.
All right, so there is it is in a CSV file format. Is that I'm under the assumption that that's something that is exported from can be exported from ANSYS.
Okay. Okay.
And so this is for heat transfer
Yes, right. Exactly.
applications.
Uh-huh. All right.
All right. Some other MFBD, so it's multi-flexible biodynamics enhancements. So export contour. And so one of the things that can be quite useful is we're given a little bit more information when you as you export this contour data. So you can select between the node set, patch set, what you're trying to export, and then also in RecurDyn V9R3, it wasn't labeled very accurately, so it could be a little bit confusing what you're actually looking at once you imported it or once you opened it up. So it's labeled a little bit more accurately now so that you can have a little bit more detail of what you're actually looking at. Delete unused materials and properties, that was talked about previously. If you have a lot of materials and properties that you aren't using, you can simplify things by deleting those. And the display component can be used in masking mode. And so there's various improvements that have been made to the display that we've kind of gone over previously, that you can select each of these different element types, and there's a check mark there, and if you uncheck one of those, then all of the elements that are of that type will be masked in the model so that you won't be able to see it anymore. And so that's fairly useful, especially when in order for RecurDyn to mesh, it had to include some different types of elements, and so you can see if maybe there's something that was a little bit off, and if there's certain regions where certain elements just aren't looking quite right. If it had to use another element, perhaps that's a region of concern for your mesh having poor quality. Similar to the feature that was talked about previously for the node sets, you can add, remove continuous, and select line or patch for beams. And this was alluded to earlier, that when you're exporting this RFA data, you can select between float and double. And so if you're a little bit less concerned with precision, you can select the float, and that will significantly increase the generation speed and reduce the file size. So you can preserve a lot of memory in that way. All right. So I had to cover regarding the. Oh,
Hey,
yes.
Zach. One quick question. Can we go back to the previous slide?
Yes.
What is shell recovery type for contour top and bottom? It's on the bottom screenshot. Right, it is to the left of the red rectangle.
Okay.
Shell
Yeah,
recovery
so,
type.
right. So that one is when you have a mesh with shell elements, and then the shell elements have a 2D topology, but there also is a thickness. So if the shell element is being bent, then the stress on the one side will be different than the stress on the other side because of the thickness.
Right.
So but as far as the display is concerned, then you have to pick one because that's a 2D topology for display. So you just pick the top or bottom so that you can see what the stresses are on the two sides of the shell.
So top defines the bigger radius, something like that?
No, it has to do with kind of the direction of the normal. So I mean, when I'm using something like that, then what I'll do is I'll just try both options and look at which way it's bending, and I will know if it's going to be in a greater tension on one side or the other, and look at it that way. I mean, you can go back and look at the surface normal, but you can also
Sure.
just inspect the value of the stresses and figure out which way it's going.
Okay, thank you.
Hey, are there any other questions? Okay, thank you. Well, yeah, let me know if you have any questions. I'd be happy to answer anything that we couldn't answer during this privately.